Hello everyone. In the last section we have talked about P&IDs, process flow diagrams and block flow diagrams. In this section we are going to read some P&IDs for several processes and then we will solve our sheet. In the last section in the P&ID we have said that when you want to indicate your control loops, you can put up to 4 letters. The first one is for the measurement, level, temperature, and so on. Second one is the device. The third one is a device or condition, and the fourth one is the condition. So for example, if we want to make a pressure controller, then we're gonna put PC. If I'm putting an alarm to say that the level is high, then I'm going to put LAH, level alarm high. Then we have talked about the symbols, and we have said that if you want to say that this controller or indicator can be found locally, so you are going to put a circle. If it is in the control room, then you're going to put a circle with horizontal line, and if you are going to say that the function is shown in the distributed control system, then it is a circle with horizontal line inside the box. Then we have talked about the symbols, about the valve, so make sure to use the lines and valves that are compatible together. If you're going to use electrical signal, use the symbol of the electrical valve, and if you're going to use pneumatic signal, then use the symbol of the pneumatic valve. Now let's start this section and read some P&ID. Let us consider this control scheme. This is a three-phase separator, which means that your feed has liquid, solid, and gas, or two different liquids that has different densities and the gas. Here the control scheme has three controllers. The first one is a level, as you can see from the left. It's a level transmitter. So the level of the first liquid is measured, then it is sent through electric current to the level controller. Here, as you can see, the level controller is shown in the DCS. Then the signal is sent through electrical signals to an electric valve to control the output of the first liquid. On the right, it's the same scheme. However, this time the level is measured for the second liquid. Then the transmitter transmits its signal through electrical current to the level controller, which is shown in the DCS. Then the level controller sends the signal to the electric valve. In the upper section, you can find PT, which is a pressure transmitter. Sends the signal to a pressure controller that is shown in the DCS. Then the pressure controller sends the electrical signal to the electric valve that controls the flow rate of the vapor outlet. Of course, if you want to illustrate, then when the level of one of the liquids increases than the maximum value, then the controller will send the signal to the valve to open, so the fluid flow rate is increased and the level is decreased. In the pressure section, when the pressure is high, then the pressure controller will open the valve so the flow rate of the gas increase and the pressure is controlled and decrease again. Now let's consider this P&ID. As you can see in this P&ID, you will have the names of each equipment written. However, as we said, we put a letter, then three numbers. The first one will indicate the location or the area, and the other two numbers indicates the number of the equipment. However, here they have a lot of areas in the factory, so they put the area, then the letter, then the number of the equipment itself. Now let's read from the left to the right. The first thing is 30V03, which is surge drum. Here, as you can see, there is a pressure controller at the top. It indicates the pressure, then a control action is sent to a valve. Not only that, but also you will have a level controller and a flow controller, and they are in cascade, and they operate a valve to control the flow rate from the drum. After that, the column 30C01, which is depropanizer. In this column you will find several control loops. Let's consider it from the top to the bottom. You will have first a pressure controller that controls the pressure at the top section of the column by manipulating the flow rate of the upper product from the column. Then you will see a temperature controller on the right that controls the temperature inside the column by controlling the flow rate of the reflux. As you can see here, also there is a cascade operation between temperature controller and the flow controller that controls the valve. Let's go to the bottom. Here you will see a level controller on the left that controls the level of the liquid in the lower section of the column by controlling the flow rate of the bottom product. Here also there is a cascade between a flow controller and the level control to control or to manipulate the bottom product of the column. On the right you can find the temperature controller, which controls the flow rate of the heating operation done in the boiler. If you look upwards, the upper product goes into a condenser that has a level controller and a pressure controller. Now you know how to read the P&ID, and let's see how the questions can be given to you into the quiz or the final. In the sheet you will find three types of different questions. Question 1 says draw P&ID system for the following processes indicating control variable, manipulated variable and final control element. In this type of question you will have the control scheme described totally for you, and you need to draw it carefully, draw the symbols correctly as indicated in the question. In question 2 it says suggest a control scheme for the following processes and illustrate what happens. Here you will suggest the control scheme, whatever you want, however make sure to make it feed forward or feed backward as the question says. But you're totally free to put your controllers. The third one says describe the following process control. In this question you will find the control scheme drawn for you, and all what you need is to describe the control, indicating the controlled variable, the manipulated variable and the disturbance, and saying what is happening in this control loop. Now I am going to solve some examples with you, and I will give you an assignment that need to be submitted before next week. Now let's consider question 1. Here it says that the liquid level in a tank is controlled by a feedback system using a transmitter that transmits the liquid level to a controller through electrical signals. The controller computes the error and sends a pneumatic signal to the final control element. Here, as you can see, we have several information. The first thing, we have a liquid level in a tank, so we will draw a tank. In this tank I have a liquid. The liquid level is controlled by a feedback system using a transmitter. So the first thing we know is that this is a feedback and we have a transmitter. So we're going to put a transmitter. L indicates level and T for transmitter. It transmits the liquid level to a controller through electrical signal. So the signal that I'm going to draw is electrical, then level control. The controller computes the error and sends the pneumatic signal to the final control element. This is the output and this is the input to the tank. So the level control will control the flow rate or manipulate the flow rate of the output through pneumatic signal, and this is the sign of it. Here the controlled variable is the level of the tank. The manipulated variable is the flow rate of the output stream from the tank, and the final control element is the valve. So in question 1, point number 2, the composition of the product from a jacketed reactor is adjusted by controlling the temperature of the heating medium in the jacket. The reactor has an indicator that is located in the plant, and the temperature is sent through a transmitter as electrical signal to a high alarm and to a controller in which the error is computed, and the action is sent to the final control element as electrical signal. First step here, I know that we have a jacketed reactor. So let's draw the reactor. In this reactor, let's say that we have A plus B to give us a certain product, P. Here, the question says that there is a temperature indicator, and all of these indicator and control system is to control the composition. However, here to control the composition, I want to control the temperature. So by controlling the temperature, I will make sure that the composition is the correct composition. So the control scheme that I am going to draw is a temperature control. First of all, there is an indicator, so we have temperature indicator Ti, and you have a temperature transmitter T. The temperature transmitter transmits electrical signal to both temperature alarm high and temperature controller. So when the temperature is high, there is an alarm that is going to be in the on mode, and the controller will start to take the corrective action. If the heat is high, then the corrective action is to lower the flow rate of the heating medium. Here is the point. In this question, it indicates that the jacket has a heating medium. So let's say it is a steam or anything, so it is a heating medium. When the temperature is high, then the flow rate of the heating medium will be lowered. If the temperature is low, then the flow rate of the heating medium will be increased. The temperature controller sends electrical signal to the flow control valve. This is the scheme. The third one is an assignment. You need to make it, draw it, and indicate the controlled variable, manipulated variable, and final control element as well. In this question, the controlled variable is the temperature of the reactor. The manipulated variable is the heating medium flow rate, and the final control element is the valve. So let's go to the second question, and in this question you're going to suggest the control scheme and illustrate what happens in your system. In the first point, it says that control the output temperature of the vessel using a feed-forward system using a cooling water jacket. What I know here is that I have a vessel, so I'm going to draw the vessel. And I want to control the temperature of the output stream from the vessel. If I put the indicator and controller here in the output stream, then what I'm going to do is a feedback system, because it senses the temperature after the disturbance occurred. However, here in the question it said that you have to suggest a feed-forward control system. So what you need to do is to measure the temperature of the inlet temperature transmitter. Then the transmitter transmits the signal to a temperature controller. The controller would know if the input stream has the right temperature or not. If it is the right temperature, then no corrective action will be made. However, if the temperature is lower than the correct temperature or higher, then the controller will take an action and manipulate the flow rate of the cooling water. Here you have a jacket in which cooling water, this is cooling water. So the controller would send a pneumatic signal to a pneumatic valve. Of course, you can say that this is an electrical signal with the electrical valve. However, make sure to draw the right signal with the right valve. If you want to draw electrical signal, then you have to draw with the electrical valve. If you want to draw the pneumatic signal, then draw the pneumatic valve. In the illustration, you would say that the system would control the temperature of the vessel by measuring the temperature of the input stream. When the temperature of the input stream is wrong, the temperature transmitter would send the signal to a temperature controller, which will compute the error and will take a corrective action. If the temperature is lower than the desired temperature, then the feed flow rate of the water would be lowered. However, if the temperature of the inlet stream is higher than the desired temperature, then the controller would send the signal through pneumatic signal to the pneumatic valve to increase the flow rate of the water. Here the controlled variable is the temperature of the vessel. The manipulated variable is the flow rate of the cooling water, and the disturbance is the temperature of the inlet stream. Let's go to question or the point number 3, and point number 2 you're going to solve it as assignment and submit it before next week. In point number 3, it says control the liquid level of a tank using a feed backward system. So I have a tank and I want to control the level using a feed backward system. The tank has level transmitter. You will have to put the transmitter nearly in all the application. Then the transmitter would send electrical signal to the level controller that sends electrical signal to the electrical valve that controls the flow rate of the output stream. When the level is high, then the level controller will open the valve and the flow rate of the output stream would be increased, and vice versa. Make sure when you are going to illustrate your system to say the type of the signals, whether it is electrical signal with electrical valve or a pneumatic signal with pneumatic valve. Make sure to indicate the type of the signal and the type of the valve when you are illustrating your system. In the second point in question 3, this is a tank. If you are going to read it from left to right, you will have a level sensor high, high. That indicates that the level is very high. And then you can find level alarm high, high. If you are going to describe what's happening here, then when the level is very high, then the sensor will sense the level and send an electrical signal to the level alarm that is working under the very high conditions. Now let's see the second control, which is in the right part. You can find LT, which is level transmitter, that transmits electrical signal to a level transmitter that is located in the DCS or shown in the DCS. Then this will send the signal to LY. Here the Y indicates the controller, so this is the level controller that is going to send a pneumatic signal to the pneumatic valve that is controlling the flow rate of the product. Kindly don't forget to say the flow rate of which stream. Never say that the controlled or the manipulated or the disturbance value or variable is the flow rate and stop. You need to indicate the flow rate of which stream. Thank you so much. If you have any question, I will be available online in the chat room. Kindly try to solve the 3 assignment questions and submit it before next week. Thank you so much.